Kraken Mare, a lake located at the northern pole of Titan, a moon of Saturn. At around 500,000 kilometers square, it is by far the largest lake in the solar system. It is about twice the size of the United Kingdom. It is far larger than the largest saltwater lake on Earth, the Caspian Sea, which, despite its name, is a lake because it is landlocked, meaning its surface is surrounded by land. Kraken Mare also has a surface area 2 times greater than the total surface area of the Great Five Lakes of North America, which are all freshwater. Now, the name Kraken Mare is a little bit misleading, just like the name Caspian Sea. Mare in Latin means the sea, yet it is not actually a sea since it is landlocked. So what I think is going on there, just like with the name Caspian Sea, is that calling it the sea, Mare, is a sort of hyperbole meant to express that it is an enormously large lake. Kraken Mare is about 60% of the total surface area of all of the lakes on Titan. This lake is mostly composed of liquid methane at 70%, 16% is liquid nitrogen, and 14% is liquid ethane. At minus 180 degrees Celsius, those molecules are in a liquid state under the atmospheric pressure of 1.5 bars. This giant lake is also very deep, with radar data suggesting that the main body is almost certainly at least 100 meters deep, with it possibly being many times deeper than that. However, not all of this lake is as deep. Some parts, like the channel Moray Sinus, are estimated to be around 85 meters deep. Kraken Mare's body of liquid behaves not that much differently from liquid water on Earth because of its specific hydrocarbon composition and surroundings. However, there are still some notable differences. Such a low density of this lake means that humans would easily sink into the lake. Also, many more things that float on water would sink in liquid methane. Kraken Mare has a very fractured appearance. There is a massive amount of rugged islands, varying greatly in size. Some notable examples are the Bermothus and Penglai Island. Both are some of the largest islands on this lake, but Bermothus is quite different as it is a part of a chain of numerous islands stretching far away from the shoreline, and it has a surface that is somewhat rugged, while Penglai Island is seemingly somewhat more isolated and it is quite far away from the coast, so it is largely surrounded by the deep waters of the main body. It's also more flat than Bermothus. Both of those islands are very approximately about 2,000 kilometers square, so they have a surface area the size of massive cities. Now, Maida is seemingly the largest, at about 10,000 kilometers square, but a closer look at it shows that it is quite possibly connected to land, meaning it might not be an island, rather a peninsula. It is also quite mountainous. From nearly every corner of the lake, there are many channel-like features. Channels like Genova and Baffin stretch about 300 kilometers away from the main body. The Tunu and the already mentioned Moray Sinus channels both form a sort of tree-like branch pattern. There are also likely many more interesting geological features on Kraken Mare. However, many parts of the lake were not captured with a high degree of precision, leaving quite a large chunk of the lake in a blur. This is a very lively lake as well. In 2014, when the same spot was imaged a year later, an entire 50-kilometer long bright spot appeared. There are a lot of explanations as to what it is. Possibly it is floating debris coalescing into a single spot, or maybe there are large patches of bubbles created by nitrogen gas. Whatever the actual case is, it shows that this lake is a place that has significant events occurring relatively frequently. Also, this case of a bright spot appearing was also captured on the lake Ligea Mare, where a spot emerged and then disappeared in the course of at least a few years. Kraken Mare is also directly connected to this second largest lake on Titan, Ligea Mare. There is a channel called Trevize stratum that is 173 kilometers long that directly connects both lakes. And also straight into that channel there is a river pouring into it. It is a 300-kilometer long river called Cocytus Flumina. Ligea Mare is a few times smaller than Kraken Mare, as it is 125,000 kilometers square, and it is more shallow. It has a depth of about 85 meters. Although Kraken Mare seems very close from above to the lakes that surround it, such as Punga and Jingpolakus, surface-wise they are most likely disconnected. However, the liquid levels match. They are at similar elevations. This suggests that there is a system of channels likely beneath the surface connecting large bodies of liquid and creating an even layer of liquid. Similar to how in different parts of the surface on Earth, the sea level is about the same. This all means that Kraken Mare is a part of a much larger liquid system. Kraken, Punga, and Ligea Mare are all at pretty much the same elevations. Only lakes that are quite small and more distant from the biggest lakes are found to be at much higher elevations, that is, hundreds of meters above, suggesting that only those lakes are truly isolated. Possibly they formed through methane rain. Tiny wave ripples, which are about a centimeter high, were also detected on the surface of Kraken Mare, possibly caused by winds, bubbles, or methane rain. Yes, there is some evidence of methane rain. Clouds at low elevations were detected on Titan in 2010, and after the clouds passed, the surface area under those clouds had a lower brightness. And after a couple of months, when the same spot was captured again, the brightness returned to normal levels. This is all likely an indication of methane being delivered through clouds, and the rain that ensued formed a puddle that then evaporated. Now, pretty much all of the data mentioned here regarding Kraken Mare was gathered through the Cassini-Huygens probe. It was launched in 1997, and it arrived on Saturn about 7 years later in 2004. Huygens actually landed on Titan, producing these images of its surface. Huygens also had 6 different instruments. However, it landed on the equator, far away from where the lakes of Titan are, which is the North and South Pole. Now the Cassini probe, the one that didn't land, successfully studied the lakes of Titan with its instruments, which it had 12 of, allowing it, for example, to detect frequencies way longer than visible light, such as radio waves, or waves shorter than visible light, like ultraviolet light. Now, although in visible light, the wavelengths that humans see at Titan's surface is obstructed, with instruments on the Cassini probe, Cassini was able to pierce through the thick atmosphere, allowing for us to see through those instruments the large liquid lakes, and understand that those lakes are actually hydrocarbons. However, Kraken Mare and the rest of Titan's surface still has plenty of unknowns that could be uncovered if we were to send an exclusive orbiter, rover, submarine, or something that flies in the atmosphere of Titan above its lakes. Kraken Mare alone, although was imaged quite well, still has large portions that were left in a blur. An orbiter on Titan alone would help us constantly monitor the activity and changes of the lake. A submarine mission to Kraken Mare would be near ideal. Although obviously it is challenging to have a submarine that can keep its internal temperature levels at a reasonable level at such frigid temperatures, and also stay buoyant in the low-density liquid. But if those problems are solved, we could get a submarine that could sample the bottom and the shoreline, determine the precise depth of the lake, image the shoreline while it is peeking out of liquid. Also, it could sense weather conditions and map the area that it is in. A deep understanding of the weather conditions could be helpful for future possible manned missions. And on top of all of that, it could just maybe detect organic life that is not based on water but rather methane, ethane, or nitrogen. Although that of course is certainly very uncertain, as at such low temperatures there are many challenges to life existing.